Hello everyone, I hope you're all doing well. In today's concept talk, we will be looking at the idea of scalars and vectors. Alright, so first is scalars. These are typically quantities that have only a specified magnitude but no direction. Okay, so these are quantities that have only a magnitude but no direction. Typical examples of a scalar that we encounter in statics is mass or distance. Okay, so examples are mass and then distance. These are typically not that important for us in terms of what we use as a tool in statics. Most important to us is the idea of vectors. Okay, so let's go to that. So vectors are quantities that have both a magnitude and a direction, as you would have obviously guessed. Okay, so these are quantities that have both magnitude and direction. The most important vectors that we will come across in statics are force and the derivative of a force, which is a moment. When I say derivative, it is a quantity that is derived from the application of a force on a body. Okay, so the examples that we typically come across are force and moment. And who says that force is a vector? This is a really fascinating idea, is that it is an accepted fact of life, repeated observations without any exceptions, that force is indeed a vector. Okay, so force is a vector. This is due to repeated observations without any exceptions. And if you come across a situation where you feel force is not a vector, please come and talk to me. We both can get very rich. All right. So typical representation of a vector is with an arrow on top. Okay, so representation of a vector. So of a vector is, for example, if I say vector A, then this is typically written as in capital letters usually, but I'm not a stickler for that. But I would typically follow writing it in capital letters, A with an arrow on top. Okay, so this is vector A. If I want to specify the magnitude of vector A, then here is what I do. Okay, so I say that, okay, I put a couple of vertical lines right next to vector A, and this is the magnitude of vector A, and I can typically also write it without the arrows. Okay, so this is the usual convention of representing a vector. All right, and then we also typically want to draw a vector. How do we draw vectors? This is how we typically do it. Okay, so first thing is when you draw vectors, you need some kind of a reference line. Okay, so let's say that this is some kind of a reference line that I have. Let me draw the vector as well, and then we will start labeling certain facets or aspects of this vector here. Okay, so here is an example. Let me call this as vector A. Why not, right? So this is going to be called as vector A. This is the reference line The direction of the vector is given by the angle it makes with the reference line. Okay, so let's call this angle as theta. So this represents the direction of A, vector A. Sometimes you'll see that I put a straight line on top of A, or I put an arrow on top of A. These are typically the same things. Okay, I'm just trying to save a fraction of a second by not completing the arrow there. All right, now this is the point where the vector originates is called as the tail of the vector. Okay, so this is the tail of vector A. The point where it ends, which is labeled by this arrow, is called as the head of vector A. Okay, so this is called the head of vector A. And then the distance from the tail to the head is called the magnitude. Okay, so the distance from the tail all the way to the head is called the magnitude of vector A. And usually when I specify magnitudes, I use dotted lines to draw them out. Okay, and this is going to be called the magnitude of vector A, which is typically just denoted as little a. All right, the reference line is most of the times arbitrary. This is just a choice that we make. Okay, so this is our choice to have a reference line. You can have a reference line that's either fixed, or you can have a reference line itself that is moving, or the reference line itself could be another vector. All these possibilities are always game. All right, one thing that I want to mention before I go on to the next concept talk, which is the addition of vectors, is what happens when you multiply a vector and a scalar. Okay, so scalar multiplication of a vector what happens. So let's say I take a scalar, and let me call that quantity as little a. Then I take a vector, which is, let's say, capital A, and I want to know what is a times little a. And the more discerning of you will say that, hey, this is vector B. Because the basic idea is that I take a scalar and I take a vector, and if I multiply them, I get a vector in return. Okay, so scalar multiplication of a vector gives us a vector. The important thing when you get a vector, when you multiply it from a scalar, is that the direction is always going to remain the same. It could get flipped 180 degrees, but it's still going to remain along the same line. Okay, so this preserves direction. So this is a vector. So it preserves direction, preserves or flips. If A is negative, it might flip the direction of the original vector, capital A, preserves direction. And depending upon whether little a is large or small, the product little a times vector A is either going to amplify the original vector in its magnitude or attenuate its magnitude. Okay, so it amplifies or attenuates or reduces the original magnitude of vector A. All right. Thank you very much.